Hey, welcome back everybody. This video is going to be about building apps and bots for social science research. So let's start out by talking about apps. And in an earlier lecture, I talked a lot about the strengths and weaknesses of digital trace data. And some of those were that digital trace data can be incomplete, it can be inaccessible, hidden behind a company's walls. It can be non-representative. We don't know who's generating the data we might be interested in analyzing. And it can have all sorts of other privacy concerns. It can be difficult to work with for a variety of reasons. So what are the alternatives though? If we go back to say survey research, which was kind of like the most popular technique around until maybe 10, 15 years ago, we find that survey response continues to drop. So far that in many cases, a lot of research projects are not viable. Second, many of our questions require data on social relationships or on social processes, things that unfold over time. And these things simply aren't conducive to survey research either unless you have a lot of money and a lot of resources to field a lot of surveys. Finally, digital trace data have a number of advantages that the old paradigm don't have, right? Even though there's a lot of weaknesses, the strengths are really strong features. So for example, size, the fact that digital trace data is kind of always on and non-reactive. And so the question I want to ask you today is, can we have our cake and eat it too? And I'm going to tell you a little bit about some research using apps that I've done and draw on some other research by other people as well to try to convince you that the answer might be yes. In fact, I think apps can get us through many, though not all, of the limitations of digital trace data. So let me begin by talking about the first app that I ever built about 6 or 7 years ago. I was interested in studying nonprofit organizations, and I was specifically interested in studying how they compete for attention on social media. At the time, this research question was just opening up. There wasn't a lot of work done on virality and how people kind of get their message out there and generate new audiences in an increasingly competitive online environment. So back then, Facebook allowed people to make public pages and gave researchers access to those public pages. So you could actually write some code with Facebook's application programming interface and grab posts from, say, any nonprofit organization. And you could also get the text of comments on those posts and some other public features. And that data, those data were really exciting, yet they still lacked some critical information. For example, it was not possible to know who's clicking on which post, who's at hazard of clicking on a post, and who might be the type of person who's engaging. Are these only old people? Are they only young people, men and women, and so on and so forth? So the interesting thing I realized after talking with some nonprofit organizations is that Facebook has that data. Facebook provides organizations with a kind of insights or analytics data that gives them aggregated data on features of their audience, exactly the data that I as a social scientist needed. Now at the time, Facebook was embroiled in a few kind of complicated research collaborations, and it didn't seem like I was going to make much progress in working with the company to get the type of data, and especially the depth of data that I wanted. So I decided, well, instead of trying to make a contract with the corporation, which carries with it all sorts of other complicated issues, why not make a corporation with the owner of the page themselves, in this case, the nonprofit organizations, and ask them for the data? Then the obvious problem is, why should they share their data with me? There's some risk involved in sharing your data, especially back then. Norms of sharing data were kind of emergent and not really worked out yet. So the idea I came up with was to give the nonprofit organizations something that they, at the time, really wanted. And that was a kind of audit of how they're doing in comparison to their peers. So if I am a organization working on organ donation, Are my posts reaching about as many people as the equivalent organization in another state? What are the characteristics of those organizations that are generating more viral engagement? In other words, it gave them some benchmarks to kind of evaluate how they're doing in social media. So what the app did, so I recruited a bunch of organizations, mostly in the public health sector, to try out the app. And what that meant is I contacted them by email, back then I even contacted them by mail, believe it or not, and we asked them to install the app, and in return, we would offer them this free audit. Now, the way that worked is they would come to this website, which is no longer up, unfortunately, and they would click on a authorize the app button, and that would then redirect them to an authentication dialog where they were told exactly what type of data they were sharing with me. And that's a nice feature of apps because it, again, creates a contract between you and the organization. And of course, we also followed strict guidelines for IRB at the time, which encouraged us to also disclose exactly how the data would be handled and all of the other kind of ways in which the data generation process might happen and what risk, if any, there were for participation. It was a little bit easier because we were dealing with organizations, which often have exemptions from institutional review board guidelines. But overall, the concept of delivering an informed consent dialogue, which we would do in a survey or any other kind of data collection, is pretty straightforward in an app. Okay, so they log in, and as soon as they click authorize, they're allowing me access to see their insights data, aggregate data on characteristics of their audience, which I can use to adjust my own theoretical interests. I was, for example, interested in properties of the messages and kind of cultural dynamics of messaging and how those did or did not predict virality. And what you see is that these data can allow you to account for things like how much money did the firm spend on Facebook advertising, how many followers did they have, right? If you're a bigger organization, you're going to have a greater likelihood of going viral simply by virtue of having larger networks, and so on and so forth. And that got me almost all the data I wanted, except for a few things. I wanted to know things like how old was the organization, what was their annual budget. And the neat thing about an app is because if you build the environment where you collect the data, you can add on whatever data collection you want. And so I decided to add a supplemental survey, a simple, think of it like a Google form, in the website that they were redirected to before they saw their visualizations, which just asked them a few more questions, which let me fill in even more of the holes generated by the digital trace data by itself. Now I had the digital trace data, both a public version, all the text of their comments, a private version, which had much deeper demographic information about 100 other metrics, and then finally my own survey. And this was a hybridization, a way of taking advantage of digital trace data and minimizing the weaknesses and risks associated with it. So I've called these social media survey apps, but basically the idea here is just apps that link some kind of digital trace data collection with a more conventional survey format. So formally, these are a web or mobile-based tool designed to allow a researcher to collect public and or private data by social media users, probably from an API or application programming interface, collect supplemental information about those users, for example, their demographics or something else that the researcher cares about, using more conventional survey methods like an online survey, and offer something to the user as incentive for using the app. Now, I had this nice opportunity to deliver something to these nonprofit organizations that they wanted. On the other hand, there's no reason a priori why you couldn't pay people to use the app. That would, of course, be expensive, and you're constrained by resources in that case, but that's another possible path forward. So how do these things work? Well, as I mentioned, the user comes onto the page, clicks an authorize this app button, which then triggers an informed consent dialog, redirects them to a privacy policy of the app and other things like that, and then begins the kind of digital trace data extraction, the introduction of the supplemental survey. Then the app does an analysis. In this case, it was comparing nonprofit organizations' private Facebook data to each other, aggregating it to a level where it was low risk to share, and then delivering a general report of kind of which percentiles the nonprofit organization fits into vis-a-vis their peers. So in the case of the VIRE algorithm, this included working with the Facebook API, working with a few different cloud servers, which I'll talk about a little later, and also the Google API to bring in some more information about the broader environment in which these organizations were competing for attention. So one thing that was exciting about this app, it was one of the very first studies to use apps in social science research, as far as I know. And we got about a 40% response rate. So that's pretty encouraging, considering that, you know, the average individual level survey response rate is somewhere hovering around 3 to 5%. Secondly, we were worried, well, wouldn't only certain types of organizations be willing to install an app? And when we looked at all the kind of key predictors and outcomes in the paper, there was very minimal evidence of selection. So it looks like, at least in this case, apps generated a very high quality sample of organizations. Now, if you want to learn more about this work, here's 3 papers linked on these slides that you can check out. Again, they look at different dimensions of how the text, the cultural messaging, also the style in which the text is delivered, shapes the likelihood that these texts will go viral. So I told you all the good stuff, but now let me cue you into some of the challenges of building apps for social science research. The first is that there are some coding skills required. Now, if you want to build a full-blown app that works on your mobile phone, that's going to require some significant coding. You'll have to register with the App Store and many other things. However, I'm about to show you about an exciting, relatively new tool from R Studio that allows you to generate apps much more easily. Second, there's kind of a competitive environment for apps now, right? Everybody has an app. So what do you got? Like, why is your app special? You need to somehow have some way of triggering interest in your app. Third, there's pervasive and understandable concerns about data sharing and privacy. So convincing users that they can trust you with their data requires some work. And fourth, just compelling incentives are hard to identify, and particularly challenging for studies of sensitive topics. Okay, so suppose you can live with all those and you want to dive in. What's the best way to build an app? Well, the really cool new technology, relatively new now, I guess Shiny's probably 5 or 6, maybe even 7 years old now. Shiny is a tool that enables people to build, compile, and even host online interactive apps, all natively, all exclusively within RStudio. So that's pretty cool. Let's look at an example. This here is a COVID-19 tracker that is tracking basically allowing the user to interact with different states and see the prevalence of coronavirus cases in each one, do searches by county and things like that. And so this isn't like an example of a social science app, but I just wanted to give you a sense of kind of how the end product might look. They can be pretty high quality, nice graphics, nice interactive, fast, everything you'd like an app to be as a user. Now, the super cool thing about Shiny is that just like so much of the R community it's very open source and collaborative. So for example, you can get the entire source code for this app at the link beneath this visual. And that's super cool because it really opens up your horizon of possibilities. There's already Shiny apps built for, say, tracking Twitter patterns, and you could take one of those, add on a survey, and then you're cooking. So how do Shiny apps work? We don't really have time to get into the nitty-gritty, but I want to give you a big picture idea so you can kind of try a few out. The first thing I would recommend is go to RStudio and just spin up a new app. You could drop the file menu down to new and then choose Shiny app and then just choose one from a template. And what you'd see is in the lower right-hand pane of RStudio, you'd see the visual interface and you'd be able to interact with it. And then you'd see one piece of code that actually hosts the app, usually called .app. Now, the anatomy of a Shiny app basically consists of 2 parts. There's going to be a user interface and a server. And basically, the way I like to think of it is the user interface is kind of like the face of the app. That's what the user is interacting with. These define kind of what the user will see, what types of visualizations, are there word boxes, are there sliders, but it can load fancy images, pretty much anything, any other kind of app backend could do. The server side is kind of, you could think of as kind of the brains of the app. It runs the analysis that you want to allow the user to do. So for example, that COVID-19 tracker, when you're inputting a county name, it's cross-referencing that with a database that's hosted somewhere in the app folder or on the app server, and delivering some data, which then populates, say, a ggplot. So it's really that simple conceptually. Now, getting into the weeds, and if you had a chance to check out the code for this, it's a pretty involved app. But take baby steps, try some smaller examples, and see what you can do. I think you might be surprised how easy it is to get up and running. And there are just so many templates out there. So do take a moment to check out RStudio's Shiny Gallery. There are dozens and dozens of really exciting apps out there. And some young creative computational social scientist is going to be able to figure out a way to repurpose some of these to answer one of our field's biggest questions. Often you're going to want to store data and have a place to put it. You can host your whole app natively through RStudio again. So when you finish building your app, you can press a publish button and it goes straight up to the internet with an address and everything. Now, you may want to do a lot of complicated hosting and storing of data. One nice function to build into your Shiny code could be to use the Google Drive package, which allows you to, as you might expect, interface with a Google Drive folder. So you could create a Google Drive folder for your app, and then within the server part of your script, you could be sending instructions about where to send the data. And if you wind up building an app that a lot of people use, RStudio can even handle that. It costs a little more each month. You can't use the free tier service, but it certainly can handle it. Again, if you want to build something more sleek and sophisticated that works across multiple platforms and works in mobile and on an iPad and on Android and every kind of different platform, then you need some more involved skills. And it's getting better though. Just like Shiny kind of really significantly lowered the bar for app building. Back when I was building apps, I was literally building them from scratch, and you had to learn reactive programming and all sorts of other complicated things. Now, again, there's so many pre-populated tools. And one of the most exciting ones is Google's Flutter. Flutter allows you, it's a software development kit that allows you to build one app, and then it kind of compiles to both iOS and Android. So if you have some fluency in a few object-oriented languages, you can probably wrap your head around Dart, which is the language that most people develop with on Flutter. And you could build mobile apps fairly simply. In the Polarization Lab, we've built a few with Flutter, and we're hoping to open source those soon. Okay, let's talk about bots. Bots have a bad rap, right? Bots are bad, right? Bots spread misinformation, bots are ruining democracy. Bots are bad. That's what I thought, especially around the time that I started thinking about a new study on political polarization and social media. It was around 2016, and I, like a lot of people, was really worried about the role of bots in, say, spreading misinformation during the 2016 presidential election. At the same time, however, I started to realize that bots, if built ethically and if built in kind of creative and intelligent ways, could actually be repurposed for social science research. So in a study from 2018, I put together a wonderful team of young scholars, and one of whom was from the very first Summer Institute, I'm now realizing. And we recruited a large sample of Republicans and Democrats to complete a survey about their views. There were also people who used Twitter a few times a week, and they were either Republicans or Democrats. There weren't any other independents or anything like that. And then we also asked them for their Twitter handle. Now this, again, was a way of hybridizing digital trace data with conventional survey data. It allowed us to collect, millions of tweets from people, their entire networks, dynamic networks over days, across vast groups of people, but then also link those to surveys, in this case, a longitudinal survey that was collected at multiple points in time. We then randomized Republicans and Democrats into a treatment condition where we offered them financial incentives to follow a bot that we told them would retweet messages 24 times a day. Now, unbeknownst to the research respondents, the bot was actually exposing them to 24 messages from opinion leaders from the opposing political party, so elected officials, journalists, other kind of media personalities, and leaders from the other party. This allowed us to effectively simulate them stepping outside of their echo chamber. And we wanted to do this because so many people thought that breaking the echo chamber would make people less radical and would make people more moderate. To figure out whether that was the case, we re-surveyed them at the end of the month. And if you're wondering how we figured out whether they were paying attention, the answer is cute animals. We, once a day, our bot posted a picture or tweeted a picture of a cute animal. And then every week we asked people whether they could identify that animal. And that's how we kind of got a measure of whether people were being compliant with our treatment. Now, again, many people, including myself, were hoping that this intervention would moderate people, would make them less radical. Instead, we saw more or less the opposite. Democrats nudged slightly to the left. The more they paid attention to the bot, the more liberal they became. The difference was not statistically significant, but it's, in my view, a small effect. And for Republicans, however, we noticed a much larger so-called backfire effect. Conservatives who we exposed to the Democrat bot became much more conservative. So check out that paper if you want to learn a lot more about the research design. We also host all the code we use to build those bots on our GitHub, and we can certainly help you learn how to set that up. One thing you're going to want to check out if you try to replicate a study like this is that Twitter has strict policies for automated accounts. There are rules that your bot has to follow. So you're going to want to check out Twitter's automated account policy, or whatever platform you might want to run a bot on. Check out their policy on automated accounts to make sure that your bot is not accidentally triggering some kind of account suspension. Okay, so how do you build a bot, right? It might sound hard, but you actually, if you've already watched my video on application programming interfaces, you actually know almost all you need to know. As you may recall, the rtweet package has a post_tweet function. And that allows you to actually post from account that you're logged into, authenticated with, onto Twitter. So for example, if we wanted to create a bot that somewhat lamely searches for tweets that mention computational social science, let's say 50 of them, and then retweets one lucky tweet every hour, this is how the code would look. We'd use the search tweets function to look for tweets that mention computational social science. We'd pick one of those using some dplyr, and then we'd just simply use the post tweet function in order to post the text of that lucky tweet. And then we'd pause for an hour before the loop starts over again. And this would run that for one day. So making a bot interactive is even cooler, but a little more challenging. So one of the coolest studies, I think, is Kevin Munger's excellent study, Tweetment Effects on the Tweeted. So he did a study of basically whether bots could censor racist language and make people be less racist in the future. And what he found was that when he modified the race of the avatar of that account, people were more likely to stop using racist language on Twitter if they were sanctioned by a white avatar than a dark-skinned avatar. So Kevin has this really kind of complicated workflow in his app in which he searches and filters apps and then responds in different ways according to what is said by different users and when. It's not super complicated, it's just really a few more lines of code, but it adds a little more complexity. So if your bot had to interact with people, you'd also want to carefully review Twitter's automated account policy, because at the time of this video, one of the most important requirements is that you don't harass users by repeatedly interacting with them without their consent. Okay, so where does the bot actually live? Like, how do you actually run it? Do you just like set it up on your laptop and then hit run? Well, you could, but your laptop might crash, your internet might go out, or all sorts of bad things could happen, or maybe you just need your computer to work, right? Fortunately, there's a lot of cloud hosting options. The one that I've always used is Amazon Web Services, but Google is wonderful too. There's a lot of great options out there. And at the bottom of this slide, I link you to a tutorial I wrote on how to run RStudio in the cloud. Basically, what happens is you open up a tab in your browser that loads what looks almost exactly like RStudio on your computer, and then you can run those even freely for some amount of time. This is also a great thing to know about if you're going to be running, if you have a high need for compute power. Like if you're going to be using a lot of machine learning, you're probably going to want to learn to spin up some VMs or virtual machines on Amazon AWS, and these slides are there to help you do that. Same thing with storing data. If you start generating a lot of data from Twitter, you're going to need a place to put it. And Amazon EC2 compute cluster is used for hosting, the app, but for storing data, you can use its S2 storage capacity. Now, needless to say, there's a ton of new ethical issues in app and bot-based research. With regard to apps, I kind of already went over a few, right? Do people know what kind of data you want to collect and what you're going to do with it, and most importantly, who you are, right? One of the issues in the Cambridge Analytica case was not that researchers weren't careful about a few of those things, but that when they went to publicly share the data, other people weren't necessarily beholden to those same ethical obligations. So, in computational social science and ethics, there are always unknown unknowns. And so I always try to say, and I think Matt has some nice points about this in his earlier lecture on ethics, in case you missed that, about how we should always hold ourselves to a standard that's higher than the IRB standard, and always talk about these issues openly and publicly and with other people, because unfortunately we're going to make mistakes, and the best way to prevent that is to talk to each other and to run small pilot studies that might, say, identify some potential issues, especially if you're studying something sensitive like racism or extremism or political polarization. So that's all I've got. Happy app and bot building. I'm really excited to see what you come up with.